Hey everyone, how's it going today? Okay, so I know we we're just starting here. It looks like we got a good number of people, and yeah, let's get going. So uh, yeah, my name's Andrew. I'm over here at Redgate. I'm a sales engineer. I've been here for a little while. You may have interacted with me before, um, uh, and we'll talk a little bit more about my background when we get there. So let's continue on. So yeah, today's webinar is going to be about how to achieve true DevOps by including the database. We're going to go over just a few slides, and then we'll jump into the the demo itself. We have these webinars monthly, and we focus on the integration of automation tools with different version control systems, as well as build and release management tools. And today I'm going to be doing TFS and our SQL change automation migration solution in Visual Studio there. Okay, so yeah, this is me. That's my email address if you want to reach out to me, my LinkedIn there. Like I said, I've been at Redgate now for about 4 years, 3 years in support. So that's where you may have seen me previously, and you may have interacted with me on some demos as well, or scoping calls and whatnot. And yeah, if you do want to get in touch, you'll probably talk to me or one of our other sales engineers at some point. And yeah, so we're gonna run through a couple of slides quickly, like I said, and we'll jump into the demo afterwards. Just a couple of housekeeping items. Everyone will be on mute throughout the webinar, but please do post your questions using the GoToWebinar panel over there, and we'll try to answer as many of them as we can before the end of our session today. I know I can talk a lot. Those of you who know me know, but I'll try to run through kind of quick so that we can answer some good questions towards the end. And then a little bit about Redgate, if you don't know. We've been around for over 18 years now. That's a year old at this point. We're 19 now, and over 200,000 customers. And we help companies improve the quality and efficiency of their SQL Server database development and deployment processes. So yeah, we have the SQL Server Central and Simple Talk hubs, and they're a really large presence in the community. Um, they share best practices, learnings, and help to solve problems with the database community. And also, we walk the DevOps walk as well as talking it. You can see that we've got around 1,000 product releases. Actually, that's a year old too. That's our 2016 number. I think we've improved that by this point. Um, but yeah, and that increases year on year. We're really rapidly increasing the number of releases we do each year. Um, and that's come from implementing DevOps throughout our organization. So we've seen it personally. And then our customers range from global corporations. So actually 91% of the Fortune 100 uses Redgate tools. Everything from single person shops and consulting services to huge corporations and everything in between. So yeah, let's talk about some of the challenges of integrating the database into DevOps processes. Um, so, uh, you know, it's pretty easy to integrate, DevOps with the application. There's a lot of tooling around that, and applications are not nearly as complex as databases. Um, you know, let's talk about a brief scenario. We want to make a change to our end application. A lot of dev shops out there are already using best practices around ALM, and rapid delivery of their application code. So that change can be deployed pretty quickly. We change the line of code and that change is just moved through the pipeline. But for the database, a similar level of change will often involve a lot of manual steps. We can maybe script the change and run that same script against different environments. Ultimately, though, deployments of databases are not as easy as swapping out old code with new, and this is our fundamental problem. We can't simply swap out a table especially as databases hold business critical data that needs to be safely preserved. And they also carry with them a state, and that needs to be managed. We can't just replace it. And because of these unique challenges with databases, this often means that we find the database left out of, DevOps. Um, and as a result, we come across a lot of DevOps who've experienced a whole host of issues. So databases out of pace with application development, and this underlines the DevOps adoption we're seeking to push forwards with, as changes that are made with the application code can be held back by the database due to those changes taking longer to push out. And databases become kind of a bottleneck in agile delivery processes. Because of this, releases are less frequent, and that makes each release more risky, not only for the database itself, but also any code that relies on those database changes, which can often be the majority. So a lot of the code from a feature, relies on the database. And we're really preventing the use of CI/CD and putting manual steps into what should be kind of an automated process. And that means that each deployment requires a lot of dev and DBA hours, which is what we're really trying to avoid in the first place. They can become stressful, demoralizing, and tasks that people want to avoid. People staying up till 4 a.m. just so that they can release to prod, when you have some downtime. And if something goes wrong, then we often have no way to trace those database changes, and that can make bug hunting a real nightmare. And we don't really have a good way to roll back often too. And so we're left with little option rather than to live fix, And so as part of the database delivery process, we need to make sure that we are executing the right changes on our target database, going all the way through to production. And we need to make sure that we have changes from all developers in the right order. And that sounds like a cumbersome task. And so what we'd like to do is kind of bring the database into the DevOps world and help you move a little faster. So yeah, enough about the negatives. What are some of the positives? What are some of the benefits if we could adopt this process? Well, what we would see is that we were able to build repeatability into the delivery process. And this means that we can continuously test the production readiness of the changes that we apply to our database. This affords us a much greater predictability, greater reliability, and faster response time. Deploying small units of change is really the key principle here. I've talked to a lot of DBAs who are required to review thousands of lines of scripts when it comes to deploying the database. Sometimes one stored procedure can be thousands of lines, unfortunately. And that normally can take days depending on how many bugs they find in that script and ordering and whatnot, any number of things. And by committing small database changes to version control on a regular basis, you can introduce automated builds and tests to make sure that all of those small units of change are tested and validated. And this happens multiple times before you are ready to deploy from dev to your next environment. And that can result in your releases being more reliable and less time consuming. And overall, everyone's a lot happier. Developers are happier as the database is no longer a bottleneck. DBAs are under less pressure because it's automated and it does most of the work and overseeing for them. And they've got a good dashboard to look at. And they perform less arduous tasks. And most importantly, the customer is happy as they get new features quicker, bugs and known issues get cleared out sooner, and their feedback loop can be greatly reduced. Everyone loves it when a change is requested and then they just see it happen, Another great benefit of being able to respond to a changing landscape quickly is that suddenly our big compliance questions, so all those IT auditors, asking, what change was made, when was that change made, who did that, what approval process did that go through, that's pretty easy to answer, when we adopt those compliant best practices. That were maybe an afterthought beforehand, but now it's integral to our process. And the steps are compliant in and of themselves, self-documenting. And we'll talk a little bit more over here too. So the GDPR requirement of data protection by design and default actually aligns really well with the core fundamentals of DevOps. Having a reliable, repeatable, and auditable process provides a really solid foundation which we can meet this requirement. So automation can help us provide a robust and repeatable audit trail, and our changes, among other things, being tracked at all stages. So we, like I said, we know who did what, when, why, when it was actually deployed too, and who approved that, you know. In addition to this, by extending DevOps practices to the database, we no longer have to wait until the point of release to see how our software behaves. We know what to expect and reduce the risk of chaotic or even catastrophic software releases. And this is key, as catastrophic failure can result in data breach, and not just in the way you imagine. So the definition of data breach according to GDPR actually includes loss of access to data. So simply having an environment unreachable can land you in hot water. With a robust change control and testing process in place, we can ensure that we remain reliable, repeatable, and consistent. But of course, this is a really big focus for people at the moment. But don't just take my word for it. So we actually have a state of the DevOps report that's available, and we do this just about every year. So some of the key findings from this year were that within 2 years, over 80% of companies will adopt DevOps, and the biggest driver for including the database is to increase the speed of delivery of database changes. And 76% of respondents have developers in their team who work across both applications and development. So a lot of full stack people in there who are used to having their applications go out in an automated manner, but maybe not the database. So if you want to learn more, visit our website, and you can download our full report there. And that's the URL. And maybe we can paste that into chat if you guys want to see it, take a look at it. Okay, so how can we help? So we talked about some of the challenges, the poor effects of not implementing DevOps, and some of the benefits of implementing DevOps. So what would a database DevOps process look like, and how do we handle the challenges to reap the benefits and avoid the poor effects, right? So as most of you know, some of the core tenets of DevOps, you check in your code to a version control system. So whether it's via our SQL source control tool inside of SSMS, or our SQL change automation tool inside of Visual Studio, up to any one of these repository systems that we see at the bottom. So we work with Subversion, Git, Vault, TFS, all the major version control systems. And then another core tenet is to use a CI, or continuous integration engine, with our SQL change automation tool to build, test, involving static and sometimes unit tests, and then package the database code, data and schema, for our static data there. And some of the most popular CI tools are at the bottom. So TFS, TeamCity, Jenkins, Bamboo, etc. And then another core tenet is to use a CR, or a continuous release or continuous delivery tool, such as Octopus Deploy, VSTS, or Bamboo, to kind of orchestrate the moving parts for the deployment and to document that whole process. Because there's a lot more than just the database. Infrastructure as code is pretty popular now too. And all these fantastic tools are really commonly used for the application code. But because of the challenges we discussed, the database team can't take advantage of them. They're left out. And the tool belt with SQL change automation allows devs who always want to be able to work faster, and DBAs who are concerned about the stability of their database, to have the best of both worlds, working faster and more safely. So that's what we really want to see with this process. And you can see at the top there we've got the dev and the ops. So devs are working in the development environment either with their own dedicated database or in a shared dev database, making their changes there, and then committing that to version control. And then from there, we really take it out to the CI/CD, so it pulls it in. We do some build validation, as we'll see. We'll talk a little bit about what that build validation entails. And then we bring that out and release that to our downstream environments. And normally we can see at the top here, the first half is generally run by dev, and then the second half is generally led by ops, or maybe just a DBA. And really we want to kind of bring those together and present a central dashboard that those teams can really collaborate on, rather than kind of being at odds. Being able to work faster as well as more securely, really best of both worlds, as I said before. And every build and release is versioned. So the ops team has a good history of what went out. The dev team can respond to support tickets by being able to trace back that release to their actual, repository changes that they made, back in source control. So yeah, just a lot more visibility, and a lot easier to track back when something goes wrong. But that never happens, right? So anyways, let's kind of go through and go through our demo. One more thing I wanted to mention, we have some other tools that plug in at the end point here. So after you deploy, that's really not the end, right? What happens after we deploy? Well, we need to monitor it. So we also have a SQL monitor tool, and we can help with the whole bringing that prod database after we've deployed back to our version control system. And we'll see that, or back to our developers and back to testing as well. So we'll see that with our SQL clone tool as well today. So yeah, well, I really want to show you guys quite a bit here. So I know we've taken about 20 minutes here. Let's go through the demo. I'm gonna be moving a little quickly because I'm long-winded. And yeah, let's go. Okay. Okay, cool. So here's SQL change automation inside of Visual Studio, but this isn't actually where we're going to start for now. Let's go back to SQL clone, as I was talking about. And what I'm going to do right now, I'm going to create an image of our live prod database. Now, this isn't something I'd recommend necessarily. I'd probably recommend taking a backup of prod and creating the image off of a backup. But you can take it from a live SQL Server instance as well. It'll cause a little bit of latency on the disk. So if you don't mind that, then go ahead. But who wants to risk that on prod, right? So for now, I'm just going to hit continue. And then let's do here. Okay. So we're going to do it from my ready roll prod. There we go. Continue. And actually, before I create this image, I'm going to delete the previous image here because I want to get rid of that because I want to keep the same name intact, and we'll see why later on. So let's see. Here we go. We just got a new interface here. If you guys are familiar with our tool, I'm gonna get rid of these two clones associated with this here. Okay. Okay. And then after we delete those, we'll delete our actual image here too. Okay. Okay. Sorry about this. For now, I'll just I'll create another image to go off of, um, or a different name to go off of here. So, okay, I'll do it to my file share there. Let's see. Okay, looks like the CPU is maxed out right now. GoToMeeting is maxing us out. So um, let's go ahead and let's skip through this just so that we can allow it to continue here. Sorry about that. We'll just create a clone off of an existing image then. Okay. Okay. So we'll do it off of widget prod here. And for now, we'll just we'll skip modifications. We'll set the destination here. Okay, so it looks like everything happened at one time. Okay. There we go. Okay, cool. So let's see what just happened here. Okay, cool. So we can actually delete our old image here. I'll try that again. Okay, cool. And then let's do this again. Okay. There we go. Cool. Apologies for the technical difficulties. This is why you don't have everything on one computer. Okay. So we'll name this just let's see. I need to check my my variables here. Okay. So there we go. Okay. Create image. Cool. So right now it's creating the image. It's using the volume shadow copy service under the hood to copy the MDF and LDF files into a virtual hard disk. And that's going to be our image. So this will potentially take a long time if I had a very large database. I'm not using a very large database here. So this will be relatively quick, assuming our assuming the computer here doesn't stay maxed out too badly. Okay, cool. So our image was successfully created. Now let's create a clone off of it. Okay, here we go. We'll skip modifications for now. There we go. And let's call this okay. Cool. So our clone was successfully created, and you saw how quick that was. That's about the same speed as what you'd get regardless of the size of the source image, and that's because the clone is really mounting the VHD over the network, and then also creating a differencing disk there so that it's fully read-writable. So right now, the clone itself is about it's about 30 megabytes, and we can see that here. Oh, here we go. 46 megabytes right there. And that's going to be the same size pretty much regardless of the size of our source. So now we'll use that, and we'll use that for our development now so that we can work off the latest copy of prod. So I'm going to go in here to SQL change automation, and I'm going to link up to that database I just created. So here we go. And let's do, there you go. Ready to roll dev right there. Okay. So we just changed the connection string to prod, our clone of prod anyways, and we'll refresh now. So, we're working out a SQL change automation here. It's our version control and deployment tool for migrations. So there's some differences between SQL source control and SQL change automation. So we have two separate offerings on the development side. SQL change automation works really well because it has a migrations approach, meaning that we can kind of tailor the scripts instead of having it deployed as a state of the database. So to give you an idea of this, in SQL change automation here, our initial script, our very first script here is our baseline. And that baseline kind of establishes the current state of the database, because most of us don't work inside of greenfield environments. We work with an existing database, an existing target. So we have to take some objects for granted. And after we import kind of that existing state of the database, we can start building on top of it. So these other scripts towards the bottom here, these are all incremental changes on top of our initial baseline here. And so, we're able to have like one cohesive script folder that represents our entire database up to this point. And these scripts run exactly as written. So you can see I've got some custom edited scripts in here, as well as some data scripts, and we'll talk about data in just a second too, and generated scripts. So these run exactly as written, so that if we need to do a lot of table refactoring, if we've got really complex changes that can't necessarily be interpreted by, say, SQL Compare, if you're familiar with it, or another automatic script generation tool, we can make those changes as desired in here. So we've successfully linked up, and we're starting to work against our ready roll test database here. We can see that our database, the ready roll test database, is identical to our projects currently, which is great. That means that prod, or actually not test here, we're actually working off of our ready roll dev. Let's just refresh here so that we can see it. Here we go. Here's ready roll dev. So yeah, ready roll dev is essentially prod, or a copy of prod, and we can work directly against it now, and be assured that the changes we're making will be compatible with the current version of prod. And also we have full access to all the data, from prod as well. So that's a great feature. So let's start making some changes inside of Visual Studio here. SSMS is a great IDE. It's a fantastic SQL Server IDE, but Visual Studio has actually gotten a lot better too. So we've got the SQL Server Object Explorer right there, as well as SQL Prompt built in. So I've got some simple snippets I'm going to use from SQL Prompt. So ATA, alter table, add column here. And I just I can press tab here and be able to choose, what our table name is going to be. So let's do something. Let's do purchases. Okay, so there's our schema for purchases. I think I'll add I'll do a last changed by column, because I want to see who last changed, this record. So let's, I'll just hit tab here, and then tab again, and that'll take me over to the column name. And then let's do, okay, cool. So that looks good. Now I'll do the data type. I just pressed enter there to go to the data type. And we'll do invar car 50. That should be large enough. Okay, cool. So I'll run that directly against my database here. And I could be working against a shared database or against a dedicated development database. I personally recommend dedicated development databases, which SQL Clone really helps with. As we saw, I could easily kind of provision myself a clone, or also clone can be automated as well. So that whole image creation and clone creation process that I ran can all be automated. So, taking a lot of work off the DBAs, provisioning out copies to everyone else. And we'll see a little bit of that as part of our pipeline too, actually. So now let's do a short store procedure, because I do want to show you how store procedures work inside of our SQL change automation tool. So let's do a customers. So we're going to do a get customer store procedure here. And you'll notice that we actually have a little underline right here. That's actually our SQL prompt, static code analysis running in the background here. And we can click on it and see the full details of, why it underlined this particular item. So why is it bad that we have an asterisk in our select list? And it tells us right here. We have the option to disable if we don't want to see it anymore. And that's only one of about 150 static code analysis rules available inside of SQL Prompt. And we've got a whole bunch here. So everything from best practices to deprecated syntax to execution rules, miscellaneous rules, performance rules, style rules, all sorts of good stuff in here. And we can actually share that because we've got a little settings file up there too. In addition to sharing our snippets in SQL Prompt, sharing our styles in SQL Prompt, etc. We try to make that really easy to share, or even check that into a repository if that's how we want to do it. So everyone can be working with the same static code analysis rules, making sure that only good code gets into our repository in the first place. That's the easiest place to catch it, is as we're writing it, before we have to refactor it, because who has time for refactoring, right? So we really do want to catch it before it goes anywhere important. So here's our select star here. I actually pressed tab over the star, and that's another SQL prompt feature. It expanded it out into all the column names here. So that helps us eliminate that particular non-best practice. for now, I'm just going to encapsulate this as a new stored procedure, and we'll get this show on the road. Yeah, one more thing about static code analysis too, especially if you're using our SQL change automation tool and you're writing the scripts by hand, you really do want to have those checked automatically at the developer level, in addition to during our CI and build process, as we'll see. So let's see. Let's call this get custom. Okay. Hit next here. And there's our new stored procedure right there. That looks good. So I'll just execute this directly against our database. And so now we have a few changes that we've made to our ready-rolled dev database, and we haven't actually imported those into our project yet. So we need to do that right now. So how do we do that? Well, we can't just click import and generate script. We don't see any differences here in SQL change automation. So what I'm going to do is I'm just going to click refresh here. And when I click refresh, it's going to deploy the contents of our project here to our shadow database. And then our shadow database is going to be compared to our development database. So the shadow database represents what's currently inside of our project. And so we can compare what's in our project over here in our shadow to the changes we've made in development here. And sure enough, we've got our stored procedure in our table here. We can actually double click on any one of these and see a comparison between the two. So we see that new last changed by there. And we can understand, if I import this change here, what exactly is it generating? What script is going to be coming out? For our stored procedure, because it's brand new, it shows as brand new right there. In addition, I could actually include table data. So if, for example, purchases for some reason was a configuration data table, that it's a purchases table sounds like the definition of a transactional table, but let's say it was. We could right click on it in here and say include table data, and it would automatically include all of the table data inside of our project. I actually have a few examples of that down here. So we can look at some of the identical objects that we have inside of our project. And you can see we've got quite a few different types of objects. And our customer table actually does have the static data version controlled. And I can click on it and we can see that it's stored in XML, but you remember that large insert we looked at? That's actually how it's deployed. So even though it looks like XML here, when we actually deployed it initially, this is what it looks like. And this was all generated by SQL Data Compare under the hood. And we've got a little guard statement up here too, so that's kind of nice. So yeah, we can handle both schema and data. And right now it's doing inserts, but let's say we edited one of the values in here. So let's actually do that right now. I'm going to edit one of the values for our customer table. So I'm going to go into, here we go. And let's view the data here. Okay. And we'll call, let's add the, let's edit the address here for Janine Abbott. So we'll do 121. Okay, 121 North Walnut there. And then let's script that out. Oh, actually, let's just script a new window here. Oh, okay. Here we go. Okay. Okay. There we go. Actually, we'll just script it at the end here. So actually, we'll just do a manual query here. I'm not used to the query designer here in Visual Studio, if you'll forgive me. Sorry about that. So let's do a new query here. Okay. And then we'll do, here we go. And we'll do, okay. And then, there we go. And then, and then, okay, cool. So we'll just run that real quick. Oh, our nvar car 50 was too small. There we go. Okay, there we go. I need to make my data types a little larger. Okay, cool. And actually, we can refresh here and see the difference there. And now it's going to compare that data as well, and we'll see that data pop up as a difference here. Okay, cool. So now we've got our data change here. We've got our schema change. So we actually, it looks like that address actually was edited inside of inside of my development database, in addition to our new customer being added to the very end there. So we've got two DML statements it's going to generate, as well as our table change right here, and our store procedure. So I'm going to just click import and generate script, and it's going to generate a migration script for me that will cover all of the changes that I've selected in here. And you can see that I have the option to check or uncheck any of these. Okay. Looks like the CPU is acting up again. Okay, here we go. So here's our new migration script. And we can see it right here. So here's our previous one. Here's our latest one right here. So we can see that we've got our new column right there, alter table, add column. And then we've got a update statement right here. Update set customer address to the new address right there where the customer ID is 1. And then we've got a new insert right there too. And you can tell that up here we actually have a guard clause for our last changed by, so that if that column already exists, we won't re-add it. And that's a feature within SQL Change Automation. It's not by default. But one thing you'll notice inside this migration script I just created, even though we have all these data changes, we don't see our store procedure change. And that's what I was kind of mentioning before. We can handle store procedure changes a little differently. So the store procedure change is actually at the bottom here in a create statement, drop and create statement. So that's our USP get customer store procedure right there. And that's actually how it's deployed as well. The reason being that we want to treat database code as application code whenever we can. And so, store procedures, views, functions, etc., can be treated like programmable objects, like application code. So we can kind of drop it from the target and then create it again. Now, that doesn't necessarily work if you got permissions on it, and you can disable programmable objects if you want, if you run into those types of scenarios. But yeah, it is a great feature for being able to work. Also, it works well for rollbacks too, because we maintain the state of the programmable object in here, and we kind of maintain the checksum. We look at the checksum of the script rather than the actual doing a comparison between the store procedures when we actually deploy, because we look at that checksum there. If you redeploy a previous package, like we'll see in just a bit, our store procedures will be redeployed, which we can't say for our migration scripts here because it's got a migration ID attached to it at the top. And once this migration script has run, it's going to be logged inside the migration log table, which is checked prior to actually deploying to make sure that none of these migration scripts are rerun. So even if you redeploy a previous version, your migration scripts containing your table and data changes won't be redeployed, if they've already been deployed. Now, the programmable objects, you can roll those back pretty easily and painlessly because it'll see that the checksum from that, from the older package is different from the current state of the database. So we can actually roll back programmable objects pretty easy. Also, one note, we also have pre and post deployment scripts in here, which works pretty well for our SQL CMD variables, which we can add either to the project or to our process as well in the deployment. For now, I'm going to click refresh here, and that's going to verify the scripts I just added. So it's going to deploy those scripts to my shadow database and recompare to ensure that everything is good to go. And then after that's done, I'm going to get this up to version control, and we're going to take a look at the actual build and release process, which we won't spend too much time on. So everything is identical. And now we can get these changes up into our version control system and deploy. So let's go to Team Explorer here, take a look at the changes. Okay, cool. So here's my commit, and I'll just enter in a simple commit message. Okay, cool. One thing you'll note, in addition to our migration script here and our programmable object, we also have a schema model here that's actually so that we can track changes in one central location. And we'll see that just really briefly. I'm going to commit all and push though. Cool. Okay. So now everything's being pushed up to our remote, and then our build will be triggered from there. Cool. Okay, so let's minimize that and let's go to our repository just for a brief moment to take a look at the files. So an important part of SQL change automation and versioning is visibility and being able to track back, like we said, who made what change, when that change was made. So maybe we can take a look at our customer table here. What if we wanted to see the history of just our customer table? You know, we see last changed by, last modified, customer email address there. You know, when were those added? Who made those changes? And we can get that, we can answer that question by taking a look at the history here. Uh, with migration scripts, typically we'd have to go searching through every single migration scripts to get that history. However, because this is the state of the table right here, the create script, and we just edit it with each commit, we've got this really good cohesive history. So for example, we can take a look at this commit, and we can see that on this commit, it looks like 4 columns were added. And we can see what that actually entailed in terms of a deployment script. So this is the migration script that was associated with this particular table change. And we see who did that. It was me here. And then I can assign blame based on this. You know, I can do a get blame right here or add a comment or whatever. So it adds a ton of visibility and it opens up, you know, new tools, new collaboration possibilities for our database team that previously were only available to the application people, right? Um, so let's go into our build here. So our build should be running. And here's our, so here's our build. Okay. Ah, I changed the name. This is the the problem with changing the names here. So during my process, I actually have a build here. So the build does build validation, meaning that it runs all of the migration scripts from scratch, everything from the first baseline, uh, and then all the incremental migrations against an empty database. In this case, I'm using local DB to do that. And then it runs all of the programmable objects to verify, you know, that this project can be built from scratch. That, you know, when we merge all of our changes together, that everything can work together. Nothing's misordered or there's no broken dependencies. It's all there. And then after that's done, we build our SQL. I am actually creating a clone of my widget prod database. In this case, I accidentally called it ready roll prod instead of widget prod, hence the issue here for our clone creation. And then after that, it would have deployed out to prod. And we can see when we look at the edit here, uh, this is all just TFS marketplace extensions right here. So everything from our building our SQL prod file here, creating the clone from our image name, and I'll rename this to use our ready roll prod here actually. Here we go. There we go. Okay, and we'll just save and queue it again. Okay, cool. And then we deploy to it at the end here. And so we're just picking up that build package that we just created during our build step here. So the build, like I said, it does that validation, and then it packages it all up into a NuGet package with our project name right here, and then a version. Personally, I'm using 1.0 and then our build ID, and then NuGet package. So a NuGet package itself is really just a zip file with metadata. So nothing fancy. You can actually unzip it with 7-zip if you want to. So our build is being queued again now. And actually, while we're waiting for that, I'd like to take a look at the releases because we are kind of running out of time. I know we got a lot of questions here, and I'll try to get to those individually via email because it doesn't look like we will be able to towards the end here. So let's let it build, and let's take a look at the releases here. So let's take a look at, say, a previous release, previous successful release. So let's see. So let's go back a little bit. Let's see. Okay. Okay. So actually, this wasn't a good example here, I don't think, but let's see. Okay, here we go, actually. So for my deployment here, my little test deployment here, I actually deployed it to an empty database just to show that it could build from scratch. So this is it actually doing that. You can see we've got all of our migration scripts here, everything from our baseline up to our latest one. And then all of our programmable objects deploying afterwards. And actually, all of this is inside of our is inside of our release package at the very bottom here. So we've got a release artifact we can take a look at. So let's take a look at that. Here we go. Okay, this is the release artifact right here. We can take a look at the reports. The most important one is the changes.html here, because this is what we actually can see prior to deploying. And that was actually the first deployment, so it actually didn't give us a preview. I forgot about that. Let's see how our build is doing so that we can, here we go. So our build succeeded. Now our release should be going right now too. Okay, there we go. So now we're watching it live. As we can see here, it's all PowerShell actually under the hood. Both the build and release are all PowerShell. Our second release here, you can see this is the one migration script we created, and this is our programmable object right here. And we can see the exact scripts that are going to be run, alter table, create store procedure right there. And let's take a look at that that log we were talking about, that report I was talking about. Okay, here we go. So here's our changes.html. This one should be populated here, and sure enough. So there's our new store procedure. There's our new column right there, just as we added. And then when we take a look at the script, we can see what's actually deployed. So this is the full deployment script right here. We've got all of our SQL CMD variables set up at the beginning. And then we get back into the meat here for incremental migrations. And we can see that our incremental migration scripts right here, got our alter table, add column, and then our DML here for our update and insert statements that were generated automatically. And then our programmable object right here, the new store procedure. And then that's it. That's the end. Also, though, during the deployment, we also check for drift. So we issue a drift report as well. That's empty because there's no drift. Spoiler alert. So yeah, this allows you to kind of have really good visibility as the DBA prior to actually deploying anything. And really, we just need to click approve when actually deploying, which we can do right now. We need to deploy out to prod. So we deployed to test successfully. Now it's deploying out, or it's starting the deployment to prod. And in the deployment to prod, I have a manual intervention step here, in addition to my create release and deploy from release. And we already saw the create release portion. That was the report and drift. That was the changes.html and drift report that we saw, as well as an update script that we can review. And we're really just setting up the deployment target here, but it's not actually deploying anything. The second step here, the perform deploy from resources, this actually deploys. And in this case, it's pending intervention. So I can go back out to my pipeline and I can choose whether or not I want to resume. I can view the logs and see, what was actually being deployed and how. So I see my alter table create in there, as well as the report. And I can choose resume or reject here. I can say, and you can see I've got my little instructions right there. I'll just click resume and we're good to go. Cool. So now it's being deployed out to prod. And it's the same NuGet package with each deployment in my pipeline here. So, the same NuGet package is going out to test as is going out to prod. And we've already tested this NuGet package against a clone of prod, right? And, when I was developing initially, I was also working against a clone of prod. So really, I validated this against prod quite a few times already. Even my test environment could be a clone of prod. So, by the time I actually get out to prod, it's kind of boring. I've already tested it so many times against prod and a prod like schema and data that, it's really, it's boring at this point. And after we've deployed here, we can start the process over again, creating an image off of the latest version of prod as transactional data builds up, masking that because we do have tools that can help you get in compliance with PHI and PII, and implementing that as part of our process, just built into the process, that whole life cycle, kind of the Ouroboros of development, going back and forth from dev out to prod. So yeah, I know we're over time now. Really sorry for going over. Thanks for hanging on with me and hanging on through some of the issues that we had. I will. I'll get to all of your questions via email, and I'll let the rest of you guys go today. Thanks for joining, and I hope you have a great day. Take care, guys.